Hey everybody, this is Larry. This is me going Q3 of the bi-weekly contest 101. Make K-Subarray sums equal. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. This one I think fundamentally is probably the hardest problem in this contest. I definitely struggled with it for sure. Um, I was, and here in these videos, I try to go over my thought process during the contest, and I spent quite a considerable amount of time on it, and you could watch me solve it live afterwards. And honestly, I actually jumped between this problem and the Q4 a little bit, so maybe a little bit confusing, but that's because I was stuck on two problems. I think that's the answer of the situation. I think for me, the first thing that I was trying to do is think about whether there's a binary search solution, to be honest. Whether, like, okay, if we could binary search on the sum, how can we do it, right? And then I was trying to figure it out, but I was playing around with some greedy, wasn't working. Well, actually, just to be clear, I actually was playing around with a ternary search function because I knew that the binary search function doesn't work in the sense that the function is a unimodal function, right? Or not a unimodal, unitonic, monotonic. In any case, it looks like a curve, right? Where you're trying to find the top of the curve, or in this case, the bottom of the curve, like almost like a parabola, but it's not quite like that, right? So for that, I actually thought that I needed a ternary search, not just a binary search. I did the math on it, on the constraints, and it looked really expensive. But to be honest, I was just stuck in it for a while, so I was kind of just trying random things because when you're stuck, why not give it a shot? The thing that really it took me a long time, and I eventually did get it. But the idea here, and it's kind of I like this problem a lot, to be honest. And I think part of I should have been able to, if I focus, and this is just like a mini retro. Um, I, I think the focus for me would have been that, or the thing for me is that if I had focused on this problem, I probably could have gotten it quicker. But I think I was just too distracted by Q4, and then I kind of was stuck on a couple of ideas instead of resetting, right? But anyway, so basically, let's say you have this input. Maybe we even add a couple of numbers just for funs, right? And that just makes K a little bit more, right? Well, what are the sums of these things, right? So this is going to be 1 plus 4 plus 1, and then 4 plus 1 plus 3, 1 plus 3 plus 5, dot, 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 right? And basically, we want all these sums to be the same. And it took me a long time to get to this point, as you could see by my time. But the idea here is that, okay, in order to make this sum equal to this sum, what does this mean? Well, this means that this number has to equal to this number, because no matter what you do to change these two numbers, it doesn't matter, right? Or like, I mean, it affects other sums, of course, but changing these two sums, the difference between these two sums is that you have to kind of you have to make these two numbers the same. So basically, that was the big light bulb in my head, right? Is that, okay, now basically we have to make it so that every kth element has to be the same, because basically if you think about it as a sliding window, you have slide in and the slide out has to be the same, right? Or the pop out or whatever, right? So that means that, this has to be equal to this is equal to this, right? And normally you might be done if this was a regular an array, but this problem is a circular subarray, right? For a circular subarray, and I do now wonder whether there is a problem where it's not circular, and maybe that's why people kind of got it quickly, or some people got it quickly. I don't know. I could believe it, to be honest, because then I do wonder if that changes the problem. But in any case, in a circular thing, then you just go, okay, what is the third element from here? Well, it's 1, 2, 3. So actually, I guess this is a bad example, or a good example maybe, because now this is perfect, and you have like, okay, you could call it a different thing. You have group 1, and then you have the other one for group 2, and so forth, right? Let's say we have another number. Then what happens? Well, group 1 now has this one as well, but this one, because of a circularness, also goes to this one goes to, 1, 2, 3. So this matches this one as well. And then as it turns out, the entire array has to be the same to fix it. But you get the idea of like just jumping, keep on jumping, and you could do some math to kind of, or you could just simulate it to kind of get all the groups, and you should be able to get it in linear time because you only visit each node once, right? But the optimization that I made during the contest, and it wasn't necessary, it's just that in my head, is that it turns out, of course, if you have some practice and experience, you could use the GCD to simplify this to the number of groups. And that's basically the idea, is that, okay, now we put it in a list. Okay, so there are two problems. I haven't solved the other problem yet, actually. I kind of jumped ahead a little bit. But basically, that's what I do, right? Now we have, if you will, sub-problems of different groups, right? It's like, okay, now we have to make all the groups the same. And this one I knew just from practice also, to be frank, which is kind of, I mean, it's if you haven't done it before, it's kind of tricky, I think. And you can maybe do a binary, this one you can do a binary, you could do a ternary search, but I think I've just done it enough to know. But the short answer is that here, let's say you want to make them all the same number. What number do you want to choose, right? The short answer is that you want to choose the median. Why? Well, let's say you sort this, maybe I should, 1, 1, 3, 2, 3, 4, 7, 7, 9. Maybe I think I'm missing a number. There's another 3. It doesn't really matter, right? But let's say we sorted, right? Why do we want the median? We want the median because if we let's make this 2 for now and make this 5, right, or something like this, right? Because if we don't choose the median, if we choose one number bigger, what does this mean, right? That means that all the numbers to the left will get, or even if you choose the median plus 1, right? If you choose the median plus 1, that means that all these numbers has to do a plus 1, and then all these numbers do a minus 1, right? And because of the imbalance, that means that it gives you a worse answer. If you move to the left by subtracting 1, that means, if you subtract 1 from the median, that means that 5 numbers have to subtract 1, and 4 numbers have to subtract 1, and 5 numbers have to add 1. So that means that it's going to be a worse answer because that's how it is. And then the other case is that if you have odd number or even number of thing, right, then what do you do? Well, it turns out that it doesn't matter because, or you could choose 2 or 5, one of the two numbers in the middle is fine, because you can think that, let's say we pick 2 and you have some answer, right? Now, if you want to move plus 1, well, it just means that 4 numbers are plus 1 and then 4 numbers are minus 1. So you could choose any number between the middle 2 number, it doesn't really matter. I just round down, and that's basically how you do it. And that's the mathematical proof. I did actually spend time to prove during this contest, even though or for the even number case, because I forget. So I just wanted to make sure. I mean, it was a very short, moment. But yeah, but basically for every group, we sort it, we take the middle number, and then we just count the score of how many moves it has to make for that number. And at the end, we just return the total count of all the groups. So what's the complexity here, right? It's going to be linear space, because, you see all the for every item, we put it in this here, so that's going to be linear space. And of course, it's going to be dominated by sorts, so it's going to be n log n. And in the worst case, we have everything in one group, so it's going to be n log n, so that's why the upper bound is n log n. So yeah, so n log n time, O of n space, and that's what I have for this one. Let me know what you think, and if you do get confused about this particular one, let me know in the comments, all right? So I can answer it and we'll figure it out together, or come join the Discord and chat. That's all I have for this one. Let me know what you think, and you can watch me solve it live during the contest now. Some secret. A circular, okay. Some of sub. The circular part makes it interesting, maybe. Minimum number of operations. And it's big. Honestly, it should just be ternary search, but it's kind of converged a little bit awkwardly though. What did I just do the other way? So it's 5, 5, 4. What does changing one operation mean? So, and then 4, right? Changing one operation means changing 2 of these. Okay, so 2, 5, 5. So that means that's going to be 12, 17. And 14, right? So how do we change that? Add 5 times 4. Oh no, this one. Other than ternary search. This one has more accepted. Let's do this one first then. Today, my graph algorithms are not good. Alright, let me go back to here. Maybe I can actually do this one. This one people actually get. Let me try to do ternary search. Maybe. No, that's too slow, right? 30 times. So 12, 17, 14, 12, right? Just a running sum. How do we make it so that I still want to make it 14, right? What does that mean? I don't even know how to do that. I knew it's practice more. Oh, today I'm just not thinking. Okay, calm down, Abby. Is there a way to be like silly befores? Okay, so let's say I increase 1, right? What does that mean? That would increase this to 13, 13, 15. Do the 15, then 1 move, 2 moves, 3 moves, so that's 6 moves together. That doesn't make sense. Oh, but then that's like... So we have to add 1, add 3, then minus 2. That means it is plus 2. So that means that we have to do 4 moves up and then 2 moves down at least. Right? And then we have to do 2 more moves. So wow. Just struggling today. Did I misunderstand this one? I don't think so. Let's see about 5, 5, 4, 4. All right. Yeah, okay, let's just do ternary search. I don't know, because I don't really have any idea. That's too big though, isn't it? I don't even know if this is right. This right? I think so, right? It's been a while. Double checking. Maybe not. I feel like I get this wrong a lot, actually. Still practicing. Do you know how to do this? Basically, that is the number that we're trying to get to. Yeah, I don't know. What am I missing? I feel like that's not quite right. This is too slow. We might have to do a linear thing. A lot of people are getting it. And even this one, so. Well, people got this one more, I guess. Okay, it is fast enough. Don't know how to do this one though. And this is yikes. Now everyone got. I mean, this is really lag behind, but I guess people did know this one more. Okay. I didn't want to convert this to 15, right? What does that mean? Just let's do +1. But that's the thing, right? Is that I don't know that I can be greedy like that. Because it's circular. If it wasn't circular, I could have. Maybe even. I don't even know if that's true. Yeah, I was so close, but I got stuck on Bellman Fort because I thought it was E square for some reason. So that means that changing one number affects K arrays, right? So that means that in order to get 15, we would have to add, but it's two adjacent, just not just pure two, so they're correlated, right? Like, okay, so we test 4. If we test 4, then do we know how we want to delete? Because there's 2 ways to get 4. Alright, so let's do 14, 17, 15, 12. Can I even do it that way? Right. Given 14 and 12, we want to have to add either 14 and 12 or 14 and 17, which doesn't make sense. Nothing weird about this, huh? Could you divide and conquer? No, we still need everything to be the same. I feel like can you just do regular binary search? No, because if it's small, okay. Is it just a median? No, it's not quite just a median per se, but if it's 2, what does this mean, right? That means that this number is linked to this number, maybe? Does it mean that every... Well, it doesn't... Does it? Oh, is it? That means that every K element it has to be the same. Is that true? Oh. Oh, that's true. That is fun. Wow. I really didn't spend enough time thinking about this one. I think I was trying to do something clever then. Yeah. Okay. Okay. Is it? But is that right? Is it only because? See, because now this links to this was 1, 2, 3, and then this 1, 1, 2, 3. So that's why they all have to be the same. Okay, I get it. Wow, that's a really tough problem, but I had to figure out how to do it. Okay. Wow, that is a tough. How is this a medium? At least the way that I'm thinking about it. I think this is a little bit awkward, but okay, fine. Okay, yeah. Okay, and then from G, C dot I dot sort, say, and then we could either do force or we just should be just the median, right? I feel like it's just a median, but my math has been very old. Oops. So like 1 and 4. We get to do. I don't. Okay. Yeah. So then. That's hard. But I mean, I actually do like this one though. If I end up to be right anyway. That's hard. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem or this contest and everything in between. How did you enjoy it? Yeah, that's all I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.